Welcome back to another programming speedrun challenge. Today we got some shell stuff, so let's get right into it. Come on, PDF. Okay. Okay, so it looks like we're doing some command line stuff. Let's bash calc.c. Can we just do part 1 and 2 together? Calc. Okay. No, it looks like we have to do both, unfortunately. You can't just skip part 1. Oh, these are both part 1. Okay, so... Okay, so it looks like we're just implementing a simple calculator. And I don't think he's talking about the number of arguments here, so I don't think this is like some weird expression thing where there's parentheses and you could stack this to infinity. It looks like it's just hard-coded to this. So yeah, this shouldn't be too bad at all. We'll have to call it calc.c, so let me grab this here. Oh yeah, and by the way, I got a key thing down here for you guys, or over here. So hopefully that helps a little bit. I saw someone say that in the comments. So yeah, let me know if you want me to fix anything else about my setup. Okay, void main, and as usual, I'm always forgetting argc, argv. I know it's just, okay. Yeah, I like the array style for this a little bit better. Where's our LSP? Okay, we can make a fake make file for the LSP to kick on. Okay, there we go. Yep. Actually, this has to be int, and we'll return 0 by default. Okay, and so we'll do some basic validation first. So if argc is less than 1, 2, 3, whoops, so if it's less than 4, shift is hard, guys. Yeah, basically this is just the error message. We'll return 1 that it's invalid. Well, no, we'll make this nice. Usage, we can assume it's like compiled to ./calc. 4 times 3. Is that the right spacing? Yep, okay. And we'll have to include a standard IO. But actually, I don't think we'll need any other libraries here. What we're doing is pretty simple. So we're gonna do arg. But this is really like operand a. Yeah, so basically now that we've checked the length of this, it's safe to dereference, right? Coming from Rustland, that's how we like to think. And so A and B are going to come after, and then the operation is going to come in the middle. And so this can be 2, and then 0 is going to be the program name, right? And so if this is 4, the max index is 3. Yep, so this is in bounds. Now we'll have to do some validation. So we're probably going to use scanf. I forget. We don't want to scan on a file input, though. We want to scan on a string. I know it's some other, it scans something. It's almost like snprintf, but for buffers. Fscanf. Maybe it's just scanf. No, we don't want to read from stdin, though. Okay. No, we don't want to do that. What? I know this function is going to pop out at me, and I'm going to be like, I'm so dumb. This is the easiest function I could remember. Scanf. Oh, no, really, we're parsing. What am I doing? I know there's some weird functions. Yeah, like these return -1 or something. We'll do this guy. Yeah, so we basically give it the number, or the beginning and the end, I guess. And maybe, I guess it modifies the end if it's not done. The base, and then the return value, if it's out of range. Oh, it says error, no, and it returns. Ouch. Why is it or? I guess these are all the same values. Yeah, because when you cast it -1, it's just all 1s in 2's complement. Yeah, we'll just compare it with long min. But the type is defined, right? How can this be? Oh, I guess it's talking about these and these are slightly different because they're different lengths, I guess. I don't know. Yeah, let's just try it out. So we're going to need stdlib. So we are going to need more libraries. That's all right. Include. I wonder, can this be, the second parameter be null if we just want it to scan? Stir end. I really hope we can leave this. Yeah, they're setting it to null here. Okay, so we should be good. Op a. I'm just gonna append this to be str. I know it's a little gross, but we can't have nice parsing like in Rust, so that's all right. So now we'll say, yeah. So it returns the integer, and I guess you just can't parse these because you don't know if it's returning an error or not. But that's fine. These should be reasonable values from our users. Actually, can they be floats? I wonder if you mentioned that. Okay, we do have to parse this. Okay, maybe we do need scanf then. Never mind on this guy. I'm really struggling with this guy. Sorry, I'm not too familiar with C. Oh. A2F. Easy. Except we want a float, not a double. Okay. I like how they just keep adding random characters until they get at the API they want. Okay, and this can be null, and it converts to a float, and the failure. Okay, this is awkward. So we can't even parse 0 because we don't know if it's an error or not. This almost makes me want to write my own parsing routine because parsing floats is a lot of fun. Okay, whatever. We'll just assume he wants us to use this API, and like, if you want to divide by 0 or multiply by 0, like, I'm sorry, you shouldn't be using our dumb calculator. Okay. So no, actually, this can be a float. Op a. This is going to be string to this. Op a to string null. Was this the base? Right, base. Oh no, I guess it assumes base 10. That's fine. And this is going to be B. And then we also have to basically match on the operator. So we should have an enum for this. I do not remember how to do this in C. Add, subtract, divide, and these have to be different, so we'll just make them increasing, right? And then here, before we do the parsing, equals, actually these should be, yeah, C wants us to have to be gross like this. This is easier. Whoops. Yeah, someone was saying you do the typedef struct for this, but whatever. It's one line. It's all right. Yeah, so we're going to default it to and, right? Because if we can't parse it, basically we're going to always assign to op and override it with the actual value we want. Because in all cases, if we can't parse it, we'll just exit the program, right? So having this default value doesn't matter. It just gives us a bit of safety later on where we can assume that it's valid. So we're going to do some parsing here. So if op str, we're going to have to do strcmp, compare this to plus, and we have to check some return code here. I can't remember what it is. And we'll figure out what this is when we read the docs. String compare. Okay, duh, it's in C string. Or I guess in C. Oh, that's funny. I guess they assume you're doing C++ because this is the header file in C++. So if they're equal, return 0. Perfect. So if I know some people, right, because if this checking if this is equal to 0 is the same as saying this, right, because we're inverting a Boolean. I think the C chads in here would actually say this is the right way to do it. But for me, as a Rust normie, I actually like having this be explicit equals 0, because that way you can basically, it's easier to match that to this actual special return value than having like some, magic not at the front that somehow makes your condition work. So if it's that, we're going to say op equals add. I know it looks a little bit useless, right? Else if we can just copy this guy. Else if, and that's too many braces, that's fine. And then here we'll handle the else case where we actually want to return. Oh, and we have to add a new line to the print up here. We'll do that in a sec. And we even print it back out to them. Look at how nice this is. So that way they know what's wrong. Plus, minus, multiply, divide. Instead, new line. And then we're going to put a new line here as well. What are you crying about? Oh, op str, right? Because op is an int and not a string, and we were printing the wrong variable. Okay, and then we'll fix these guys up here, right? So this is minus. This is going to be subtract. This is going to be multiply. I suck at spelling. This is divide. Okay, so that's everything handled. We're parsing the floats. Then we're basically going to do, we can actually do a switch here now because we're not comparing strings. We're going to switch on op. Actually, do I like switch? No, I don't like switch. Honestly, switch as like the philosophy of switch is nice, right? To being able to declare all your cases in one place, but just the fact of needing break and being able to forget break and have carry through is just so nasty. I'd honestly rather do it with if else. It's more explicit. So if it's add, we're going to say result equals 0.0. And then if it's add, obviously it's going to be, we get op A. Oh, and we have to do error handling for the above. Plus op B, right? Subtract. Yep. Subtract minus. Okay, let's see if I can get the VIM stuff correct this time. Ooh, there we go. Multiply, divide. And then otherwise this is unreachable. Otherwise we return this. And then I think we want to print out the result, right? I'm not sure what's going on. Okay. Yeah, so we do the parsing if it's not valid. We'll also have to handle divide by 0. I think he just does want it to print it. I can't see where this is typing. Yeah, because he's talking about bash. You can do this in bash, I guess, and I think it just prints out the answers. So we'll just do that for now. And then I think he doesn't want any padding or anything, just the raw answer. I mean, that makes sense. We'll do /n to make it nice, and then we got to do some error handling here. So if op A, this is so gross. You literally can't parse 0 because you have to think it's the error. But if it is 0, we're going to have a pretty normal thing here. Invalid. What's the math word? Operand. Yeah, only real numbers. And this is going to be OPA STR. This is going to be basically the same. OPB. Yeah. OPB. Valid operand. We print it out. We just have to change this to make sure we're telling them which one is wrong. Please use real number. And we can actually test this. So we'll use Clang because we don't have GCC. Okay, yes, good. It gives us the usage if we don't give enough arguments. So we just do the usage 4 times 3. Yay, that seems to work. Okay, what happens when we want to divide by 0? Oh. Okay, normally I would ignore this because it seems like he's leading us towards using this function for converting. But the fact that he says to handle divide by 0 means that we have to be able to parse 0, which we can't because 0 is our failure case for this guy. But what we can do is, oh, this is so ugly. So we're going to basically string compare this. We almost want to string compare like this and 0.0 and this and like 0. And we'll just leave it undeclared here. Okay, so if it is equal to any of these things, which might be 0, so 0 point or 0.0. We should just make a function for this, but oh well, it's a school assignment, I don't care enough. OPA, right, and then we have to basically do the same thing here. Oh, this is getting ugly so fast. Yeah, I need to get better with VIM stuff too, of like actually switching between characters, because I'm good with like the base stuff, but that's about it. Oh, and we're going to change all of these to B. Whoop, B, 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 B. Okay, and then this is the parsing, except we only want to check if scanf failed if we're actually running it, right? Yep. Yep. And then if it's not one of the zeros, but it's something invalid, then this will fail and we'll catch it here. Otherwise, we should be able to parse the 0. I'm just going to make sure that I copy pasted this right. BBB, BSTR. Okay, let's try this. Nice. Okay. That's cool. That actually, it gives us floating point infinity instead of doing like a weird signal handler or something like it was 1970 with some like store in C stuff. Okay, so we have to handle this now, but only for divide. So if we're dividing and OPB equals 0.0, yeah, we'll actually just, he said this is an arrow, so we want to fail the binary. And I don't like typing. And so we'll just print that instead. Okay, so that works. I'm just going to test all the other operations really quick. So 1 plus 1 is 2. 1 minus 1 is 0. 1 minus 0 is 1. 0 minus 0 is 0. Oh, we can get into some really dirty floating point. Huh? Is that not valid? Oh, interesting. Okay, I guess C doesn't let you parse -0 even though it's totally a valid floating point number. Cool, I think this is done actually. Let me see. So we parse this. We have our error handling for the operations. We parse A, we handle it. We parse B, we handle it. We handle divide by 0. We print out the result. Let me just finish testing this actually. Oops. 0 times 0 is 0. 0 times 1 is 1. 2 times 1 is 2. Okay, now we'll do some division stuff. Okay. Yep, this seems to work fine. And that's called calc. I skimmed this whole paragraph. I never actually read any of the sentences. We're going to assume this is okay. Okay. Now he wants us to modify it and copy it. Okay. Yep. So we save the first part and then. What? Oh. Oh, it's like a really garbage shell. Oh, duh. Yeah. Making a shell. Yeah. Okay. What is this factorial business? Calc. It's interesting. I wonder how he wants us to check for commands. And then we have to spawn it. Okay, this isn't too bad. This is like a special case of a shell. This shouldn't be too hard at all. I wonder, what is he saying about factorial? ls. Oh, so I guess we don't actually read what's in path. We just check these like certain hard-coded paths, right? So we have 3 programs we can run. Okay, I like how he does it in 2 parts. He kind of gives you another like simple program you can run. We're gonna have to copy this in, I guess. What is this called even? Oh, factorial. Yep. And then we'll compile it. Factorial -o. And sleep time. What? I don't want to sleep. Oh, I guess it... Oh, maybe he was showing off... Is this slower? Oh, okay. Yeah, I guess he probably sleeps at every iteration or something to show that it's exponential. Yeah, sorry guys, I don't really go to class, so I don't know what's going on with like these weird programs. Okay, so we got factorial. It's compiled. I'm going to move a.out to be called calc. I think that's what he wants us to check for. Yep. Let's see. ls. Are these like ls-l? Oh no, he's spelling it out. ls. Okay. Calc. Yep. Oh, we'll move this to... This actually has to be factorial 2. And I guess we only check for those. Okay, so I think the... Here, let's copy over our other solution to calc.c to be... Huh, he doesn't want us to use initials. Oh, no, he does. I think this calc is supposed to be calc initials too, so let me fix that too, actually. Calc.c, calc tn.c, and then we'll also copy calc tn.c to myShell tn. Okay. Yep, that's gone. That's fine. mySh. Okay. This is going to be a pretty... We're basically going to reuse none of this code. I don't know why he's having us copy it, but oh well. Yeah. I guess we can keep the imports at least. And we don't have to... So, for our... It's not even... It's not really a shell, right? Because we just kind of run programs when we get it. We don't actually wait for input interactively. It's a little confusing. Yeah, okay, so modify the copy. So that means we do get what we're going to run from here instead of from standard in. So that's fine. So anyway, I'm thinking, so basically we have to check 2 paths for running stuff, right? So inside, actually, oh, this is going to be really interesting. I bet everyone in the class is going to hard code the path of ls to be like /user bin ls or /bin ls, but on XOS I don't have that. So yeah, that's awkward. The proper way, we could just execute which, and yeah, so I think that's awkward for us. So basically for system to path for ls, right? And then we're also going to check for to and calc, right? And then reading from the current directory, that requires actually no, that's a little extra. If we were doing a shell, we'd want to do that, but actually we can just like append / to the string of like factorial or whatever the user is looking for. That'll be a little easier. Yeah, and then we just run it with whatever arguments they give. Cool. Okay. So this kind of makes sense. If the command is not found. Yeah, so it says we're explicitly checking, so we're not actually really searching. We're just, instead of asking the file system, hey, what's in this directory on the path, we're saying, hey, does this factorial binary exist? And so actually, we can do quite a bit of validation up here. of like if, yeah, so we get the number of arguments. If it's 0, they didn't specify anything. This is going to be, I forgot the like Unix thing to show like multiple arguments. I'm gonna, hopefully that's clear enough. And so here we can literally just check for these 3 things, and if it's not that, we know we're not going to find it, so we can just error out. So actually these should really be const, because we don't want to modify them at all. It's kind of gross how it just gives us random pointers to stuff that's in environmental memory, but whatever. Oh, excuse me. So I'm going to call this program argv0, and then here we can just do some string compare. So if any of these aren't 0, which means that, no, is this logic right? Actually, no, we can make this even stupider. We can just do if else like this. So actually, it's fine like this. So we should really just list out the possible things you can run with it, because you can literally only run three things. So factorial 2 or ls, right? And so if it is factorial 2, we can just handle this whole case here, right? And then we get the else block, right? So if it's factorial 2, if it's calc, we'll check for that. If it's ls, we'll check for that. And then otherwise, return 1 and say we'll just totally spell it out for them. Unable to execute. Factorial 2. Typing's hard, sorry guys. This is funny. This has to be like the worst shell ever. It's not even a shell really. So yeah, now we can just handle all this. So we need to find ls path. Maybe there might be a library function for this actually, instead of messing with this. Search directories and path. Of course, Windows has a nice API. And not that anything in the Win32 API is nice, by the way. Yeah, I guess there is no like C library function for it. We just have to raw dog it. Oh, yeah, that's Win32, guys. Yeah, no, we're not looking at that. You know, I actually wish I wasn't using NixOS. If I was on Ubuntu or something, I could just hard code this and it would totally work. That's fine. We'll execute which. I want to find example code though. This is something totally copy pastable. Actually, let's consult our good friend ChatGPT. Okay. Okay, that should be enough. Oh yeah, so this was for, by the way, so the keyboard thing is hopefully working for you guys. I took an open source library called, what was it, OSKD? Yeah. Yeah, so this guy was like one of his first Rust projects, literally learned Rust for 4 months and then made this entire thing that's like front end, back end to basically render, key presses and stuff down here. And it's really good. But the problem was this, basically the privacy features, right? So if I run sudo here, I'm not going to type in my password, but the keystroke should be hidden, right? As long as this is running. And then when it stops running, it'll work again. So basically, I just did some stuff to check that for sudo. Good, this is almost done. Yeah, so that was this, if you guys are curious. Yeah, nice. Yeah, so we don't want a main. We want a function we can call, which makes it easier to copy paste. That's interesting. Oh, I guess so we can have the output. Hopefully this won't dump it to our std out though. We'll see. Come on. A couple years we'll have really, really fast LLMs, but we're not there in 2024 yet. They're pretty good though. It's not like I could type this fast and with 0 spelling mistakes. Free buff. Okay, nice. No, I don't want the main. I just want the code. Oh, and we're going to have to include way more stuff. Okay. And the academic integrity might get mad if I don't mention that. Oops. So we'll just we'll say that. Did I get the imports? There we go. And some of these are duplicated. Yeah, string lib io. Okay. Oop. There's string. Okay, nice. P error. What is this? Oh. Throw? You can throw in C? Oh god. Please, no. Huh. The thing is, we don't want to log. Like, I don't care which thing's failing. I just want to handle that it failed. Okay, I'm going to assume this is good code. I don't want to read all this. Returns a char pointer. I think we malloc in here somewhere. Yep. Buff size. Yeah. We want to adjust that. Hopefully it doesn't... This isn't totally pwnable. So yeah, it looks like if the piping fails, if fork fails, we handle it. We free the buffer. Okay. That makes sense. Yep. Okay, so we basically fork and then execv to basically go into which? Yeah, it doesn't return. Okay. Otherwise, we read from the buffer, buff size -1. This is, where's this defined? 1024 malloc. Yep. Yep. Okay. This actually num bytes is greater than 0. This will never be more than this. So worst case, we null terminate it. Otherwise, we free it if it failed, and then we wait. Okay. This code actually looks solid. What are you crying about? Oh, did I? Oop. Okay. So, and if it's ls, we're going to say what? You mean returns int? Oh, I have to declare it. I love how int is just like the default return type in C, and how that's actually like a totally a valid thing. Oh, and we have to specify program here. So, okay. Yeah, so when we're done, we free whatever buffer we had, or we have to check for this. This should really never happen, unless we're out of memory or something weird. Okay, so then once we have that, we basically want to check, what's a good stat64? Yeah, I like stat64. Yeah, we can give it a, yep, perfect. We can give it a path directly. Yeah, so it'll make it nice and easy. Then we give it a pointer to a buffer to write to, which is this struct. And then if it fails, we know it failed, and we can look at the size or whatever if we want to. Otherwise, we'll just assume it's good to execute, and then we'll execute it. So yeah, let's do that. We might have some of these already. UN type stat. Okay, yep, we're good. So now we have to make this path, unfortunately. So we got to do some annoying string stuff. Let's see, what is it? There has to be like a string cat to concatenate. But the thing is, what about, I think we want string cat n for the lengths. S might be Microsoft only. I'm not sure though. Strcat S, des size source. Okay, we want this. Yeah. And so actually we can totally reuse this buffer to the path, right? And then we shouldn't have any crazy long paths like this. Even in the Nix store, the hashes are pretty compact. I guess it's not in the Nix store, it's in this guy. Actually, so if I do which ls, yeah, okay, it doesn't do weird symlink stuff. Because actually this is a symlink into the Nix store. But even then, this length is maybe 100 characters max, so we should be fine. Yeah, so we're going to define buff size so we can use it in multiple places. Path to the ls. Null on error. The and it's not great because there's could be a difference here if you're thinking about it in terms of null terminated versus raw bytes. Yeah, so hopefully this will help anyone using our stupid program, which is no one. Then we can do that. Yeah, so we got the path here. And we want strcat s because we're secure. And the dest is going to be ls path. Oh, the size. Buff size. Why are you crying? We'll have to include it somehow. What's this called? myShell. Okay, I don't know what header file this is in, but we're going to find out. String.h. Oh, I might have to specify my... okay. That's probably why it's crying. Yeah, so I guess we just want C11 for this function. Oh man, I hope the graders... they're not grading on like C85 or something dumb. So okay, C11. Okay, hopefully this works. But what header file is it in? Are you kidding me? Should be in string.h. Oh, we might have to define some weird constant before we import it. What? No, not safe C, bruh. Oh, no, this one. The maximum number of characters to be... but then I have to keep track of how long... Okay, whatever, we can roll with this, because I don't know what's going on with this other function. So actually, this is going to be the number of characters we can append, which is going to be buff size minus ls path, right? Minus 1 for the null byte, right? So we're going to append that, hopefully safely. So when we do which ls, does it give us? It doesn't give us a /. So the first thing we're gonna do is append a slash. Then we're gonna go in and append. Oh, I'm dumb. Actually, we can just append this all at once. And then I just want to check this is okay. Okay, so we're gonna compile this guy. We don't need this. We should get the warning. Oh no, that's still mad. Why are you crying? Oh, it's some GPT thing. Buff size, yeah. This is gonna be buff size from here. Yep. Nice. Okay, so we need to specify something. We're gonna go with ls. Oh, we're looking at. Oh, so argv0 is our program. Really, we want to look at their program, which is this. Okay, nice. Why is that printing? Why is there a new line? What? Let's just make sure we're doing a new line here. What? Is this this should be the only thing printing, no? Oh, that means something weird is going on for sure. ls path. We printed before. Oh. Oh, does GPT append it for us? Which ls? How is it? What? Which args? Hold on. I'm so confused right now. Is n like the number of times to do it or something? Hello. Yep, that's dest. This is dest. ls path. And these are all new lines, right? Huh. These are null. Yeah, this is null terminated before for sure. Thing is though, I don't know why it's giving us the whole path. But honestly, if it is, that makes everything a whole lot easier. Because we can just check this. Okay? This is going to be just the name. Oh, we have to manage if we're going to free this or not. That gets awkward. Oh, that gets so awkward. Do we just memory leak because we're about to exit? Honestly, yeah, let's just memory leak because we're about to exit the process. Don't do this at home, kids. So we're going to have a const pointer. This is going to be actually the path for the program. Assigned to null by default so we don't get weird stuff if stuff happens. We're going to set this to /factorial. Oh, I hope execvpp or whatever doesn't need a full path to this because we're going to have to. We are not going to free this later. Because we can't, the problem is, so these are static strings here, right? And so we can't free these because these aren't allocated by malloc, they just exist in the binary. But the problem is this path, we are going to, yeah, actually we can just assign this in here. Yeah, we can just assign this here fully. The problem is this has to be malloced. But we can have another boolean that's like, we'll just set it to false by default. Okay, we're gonna need std bool or something dumb. Std bool, let's go. Are these okay? Yep, define to 0, and this can be bool. Oh no, it's lowercase, I guess. Yep. And then here, if we get it from this, we set this to true. True. Yep. Please. This is program path. And if it's null, yeah, we don't have to free it. Okay, we signed it to be free. And then here, this gets easier. If we do this, we do this, and then we free it. Huh? What? When is that actually a helpful warning? Like, I'm gonna type the pointers I throw to free. It's like it's my struct. It's not memory anymore. So why do you care that it's a char pointer or not a void pointer? Like, come on. Okay. We don't need this debugging anymore. We signed a program path. Yep, we free it. Okay. Unable to print. Otherwise, we get the path. Yep. Now we need to check if it exists. So we need to prep our nice little fstat struct here. Here in kernel. Yeah. So it's going to be struct stat. Whatever, we'll call it file. And it's going to be mutable. Now we're going to call fstat. Or I guess it's just stat on the path, right? Yep, path and buff. Path is going to be program path. It's going to be file. And then how does this fail? Okay. So I love how all the different like OS and Unix C things all return 0, 1, or -1, but you never know which one. So on 6 says 0 is returned. So if it's not 0, it failed. Which this will happen in for the local things, but it shouldn't happen for ls because then I think which should fail because it won't find. Actually, we might just get an empty buffer from which if we don't check the exit code already. Anyway, we're just going to print out program path. Otherwise, honestly, for debugging, I just want to check if this works. We can just print out like. We'll just print out the size, right? That should give us a reasonable thing, and this is going to be %d. Or whatever other weird thing it wants it to be. Yep, we'll do that. And run this. Really? You failed to find that? So on... What? On success, 0 is returned. So if it's not 0, we failed. And we have to remember to... No, actually, not always. We should we should have a go-to. So how do we do labels again? Let's go. Except we want to exit with a code, so go-to is not great for that. But we already printed, so it's fine. Yeah, so this path definitely exists. Failed to find file. Maybe because it's... I don't think it'd be a symlink, right? Yeah, that's very odd. Oh, is this somehow... What? Honestly, let's print the size anyway. Let's see what happens. Okay, that's what I thought. Very odd, very odd. And this is null terminated, right? Arguments. Okay, so I think this lstat does links, right? Okay, Yep, so we want to follow the sim length, so stat is the right answer here. Yeah, this is very odd. I'm not sure why this is happening. We should check Arno. Otherwise, I have no idea why this is happening. Do we have to dereference Arno? I forgot all about Arno. Is it a function? No, it's a macro that defines like a weird pointer expression, right? Arno. Oh, duh, we have to include it, that's why. Let's see. Yep. It dereferences Arno location. Let's go. Attribute const, interesting. Yeah, let's see what's going on here. Arno 2, what is Arno 2? It should be defined. Where's the list? File not found, really. Okay, yeah, I guess Python prints the error code. So it's definitely message file or directory, yep. Very, very odd. I'm not sure why this is happening. You know, this whole side tangent of working around Nix with some fancy magic might have actually just been a useless tangent. We might have to just assume where it is. Maybe we could run uname. But then that's even more assumptions, right? Because then we're scanning for NixOS and then assuming that this path exists instead of using which or anything, which is also gross. Yeah. It's almost easier to write an actual shell that just looks through paths properly instead of just looking up random crap on the file system. Oh well. Yeah, I'm pretty stuck on this, guys. I'm gonna hope magic idea comes to me. Otherwise, we're kind of screwed. Is this really not like? You're telling me if I do this. What? What? That's interesting. That's very interesting. So these strings are not the same. I thought they were. That's odd. But let's do it in, I should have done this from the start, printing this in tickback so we can easily see what a program... Oh shoot, was I searching... Do we assign a path? Okay, we do assign a path, good. These program path and program name are both eerily similar. And let's add some nice new lines here. New line, new line, new line. Okay, I think that's it for now. Oh, duh. Oh, because which is, yeah, it's giving us a new line. Okay, so let's get rid of that. So numbytes is greater than 0. We also want to check if buff... Yeah, that's yeah, that's very unfortunate, guys. I'm sorry about that. So if numbytes, this is where the null terminator should be at the end. If the last one, which can be nullbytes -1, which is this works because we're in this if, so that we don't go out of bounds. If this equals the character new line, we're just going to assign this also to 0, and that should fix this. Same error. At least the new line's gone. This prints right. Yep. Very curious. Interesting. Yeah, I really don't know what this is now. Are we still using the hard-coded path? Oh, that'll do it. Program path. Oops. Okay, nice. This looks reasonable. Yeah, so actually, we should be able to check this. It's giving us, where's the size? Oh, it's to, oh, because Core tells one binary that they just look at the path. Yep, 1.4 M, 1.4-ish M. Cool. Yeah, so we got the right file. That's the hard case for ls. That's done. These other guys should be pretty trivial. Do we even need... Honestly, screw it. We don't need this stat at all. We'll just run exev, or fork and whatever. Does he want us to do a specific strategy, actually? Yeah, we don't need to check it explicitly, because then that syscall will fail if the executable doesn't exist, of course. But that was good debugging, though. I didn't actually realize there was a new line there. Where is this? Okay. Okay, we have to change our path. We also have to get our current directory, it sounds like. Okay. Okay, yeah, so we have to do some path manipulation. That's fine. Wait, but is this really path, though? These path and the current directory are two different things, and I think he just means us to change the working directory. Yeah, let's see what GPT did for this. It's basically going to be the same thing, actually, where we just fork and exev. Or what variant are they using? execvpp. Yeah, we're probably going to want the more complicated one, which takes like the whole profile and everything. execvpp. Yeah, we want this. Are we setting to null here? I don't know. No, we're not. We're not passing at all. So actually, oh, after we fork, we can just change the current directory, and then we can do the execv. The problem is this. What assumptions does that fall into? Because when we run the shell, we're assuming that this is in the current directory. So we almost want to get. Let me think about this. Does this even matter? No, I think he said these are always in the current directory. He said something. Where did he say something about bin? Okay, I think we do have to get the current working directory. Yeah, there's a couple ways to do this, but they're all a little bit gross. Let me think about this again. Yeah, I don't think he... As long as we specify a full path, that should be fine. Yeah, so we can just get the working directory as we're executing, right? Nice, we can just use this. Perfect. Yep, and then we can just put these paths together here, right? So, actually this gets a little more complicated, where now we do kind of want to malloc stuff. How gross do we want to make this? Because there's kind of a couple of cases here. If it's these, we want to check the current directory. Honestly, making the real shell is going to be so much easier than this, having to like deal with weird edge cases. So yeah, that's fine. We'll just do, if it's either of these, then we'll check both. Yeah, then we'll do the actual check in here. As if we're doing that. Else if, then we're going to check this guy. Oop, too much. Okay. And then else, that else doesn't need to exist. But someone's crying. Okay. So then in here, we're going to have to get the current directory. So we'll use that the code here. And then we'll say buff size. This should be way bigger than the max path thing. Size of, this works. Static buffer, yep, 1024, CWD. Let's test this actually. Okay. Yeah, then we can do this strcat n business. After we get that, we're not going to return. Okay, maybe p error is the right way to handle errors in C. I haven't heard of that though. I guess I haven't worked with C closely enough to really know that. You know, maybe it's actually, someone in the comments is going to be like, actually p error is better because it tells you the information with error no, and here when you're doing printf, you lose that information. Yeah, you're probably right, but also this error is never going to happen. So we'll just roll with it. So, yep, we do that. So here, actually in both cases, we want to set program path to be CWD. And then also we have to make sure this is off by default so we don't try to free this memory on the stack. That'd be unfortunate. And so we're going to assign it to be that. And then here we're actually going to append the right thing to it. So we're going to do what is it, cat n? Oh. I guess we could also do the length checking ourselves to know that it's actually safe. Is this, where's the... Oh, stir n cat. Yep, okay, I guess they just add the n at different offsets every time. Hopefully we have this function. Nice, okay. So dest is going to be... this program name is really messing with me. I'm just going to call this arg because this program path is really what we're after. That makes it a little confusing. So we're going to append to this factorial 2, and the length, this is remaining, right? This is count. And cat. To be appended though, that's the problem. Because now we have to do buff size minus the length program path minus 1. And this is no longer const actually, because we're going to be modifying it. It's the same thing here, except it's slash. Okay, this should sort of work now. Let's see. Factorial 2. Path. Why did that not work? Yeah, but it looks like it got the working directory fine. Factorial 2. This is definitely running, right? Oh, I guess not. Oh, did I misspell factorial? No, I think this is spelled right, right? factorial 2. This is totally spelled the same way. What? And this size, program path, it's null terminated. Size should be pretty massive, right? I guess this branch isn't running. That's interesting. So then what is running? Arg. Oops. So this is our arg. Oh. Yep. Gotta learn overloading integers as results. There we go. Okay, that's right. We can delete this annoying debugging. Yep, so that append is working, factorial 2. Now this should be an actual file we can run. Yep. And so now this should actually work for calc as well, right? Yep. Yeah, so okay. And let's try this with ls actually. Yay, okay. So at this point we're here. We have our normalized path. We can change directories if we need to. Yeah, now we just have to execvpp some stuff. So it's actually going to be literally this exact code. What did he say about current directory though? That was something interesting. Yeah, so I think path setting to the current directory, this is just so that the child, we're actually able to spawn the child. Because we're using absolute paths, I don't think this matters. And so we'll just leave the environment alone and only like pass through the arguments basically. And so we don't need a buff. We're not doing any dupe stuff. We're gonna have to wait for the child. That's fine. But yeah, we don't need pipes. We don't need buffers. So running path. Wait, is this defining? Oh, that's funny. I guess I asked for C code. Yeah, it's defining like C 1921 over here, where you have to define all the local variables before you use them. So fork failed. Yeah, actually, I will research this. Maybe you see guys are right. I should use this weird PI error business. Okay, so if we're in the child, we don't care about any of these streams. We don't care about the path. We literally want to use the same. Actually, we can make this mutable, make it gross again, and then we can literally just swap out the first thing of this to be the thing we want to run. Right, and then all the arguments are going to remain the same, which makes this nice and easy, actually. Is this... I'm going to assume that's null terminated, and if it's not, hopefully we'll get a sig fault. Sub 0 equals... You know, for debugging, we should just print this in general. Actually, this is gonna be nice. We won't. This is the one case in the whole program we're not gonna have a new line at the end of our string in printf. So we're literally just gonna print that next part of the path. argc sub I. V, yeah. C, yep. Okay, we're getting there. We need a space here, and we'll just do a printf slash. I guess we could do puts, but whatever. Do printf at the end with the spacing. So now it should say, Oh god, okay. Oh yeah, I guess we don't need any of this stuff. We literally just want to wait for the child. Yeah, I guess eventually. So the thing is, this isn't really a shell. It's literally a one-off thing that we run. And so I almost want to just not have a parent and not fork, and then that way we don't have to deal with this child business, because it seems like when the child finishes, we want to finish normally. And so that would just make it simpler by deleting the parent and basically executing directly into the child. Actually, does he say anything about this? Yeah, he doesn't say anything about running it multiple times. Like an actual shell, you sit here and you write each command, right? But it seems like what he wants is that we run ls and then it exits, right? So, yeah, actually, yeah, we don't need to fork here. One less thing that can fail anyway. So we don't need to wait. Oh, we don't need cleanup either. Nice. I wonder though if we end up going back into a C program because it overwrites it, if it'll reuse the same heap. No, I guess it would rerun the C initialization code for the binary, which probably just wipes all that stuff anyway. Yeah, and this is going to be... Oh, that gets awkward because here we really want to find the last... This is the name, right? Not the program path. What is this? Oh, file. Okay, actually, we want... Never mind. We want this to be the same for both. So this is file. We printf this stuff. Okay. Oh yeah, and then there's no error handling, right? Because we just do stuff. What? Oh, I think we are running ls, but there's another argument on here now. Ah, yes. So we actually want to shift everything in here one back. Okay, so we're subtract after. So we're going to say argv sub I minus 1 equals sub I. argv, I cannot type today. And we're going to go for 1. Whoops, sorry, I mean starting at 1. Right, and so basically this is going to shift. This will work, yeah. This is going to shift all the elements back 1, right, to make space. Because basically the way it's running right now, we're running a.out ls leh, right? But when we want to do the execvpp, we actually want this to be ls-leh only, right, where ls is the path. Whereas right now, we're overriding this index 0 here to be the program path, so we're really getting, this is what's running, right? The whole path to ls leh, which is the same as me typing ls, or actually I can run the whole thing here. And of course there's no ls file, right? Because if ls, there's no ls file. So this totally makes sense. We just have to shift this back and then reassign 0 to be the child. So hopefully this might work now. No seg fault. Yay! So we can run ls, we can run calc, 1 times 3, this is 3. We can run factorial 2, let's say 10, 1, sleeps, and then gives us the result. Yeah, I think this all works. I wonder, does he care about logging? Oh, so we have to display error messages. So if we do factorial like this, that doesn't work. Actually, this should... Huh? Oh, the last the last argument is being duplicated because we're copying things back. So after this, argc minus 1 equals null. There, that fixes it. Okay. Yeah, because basically before, if you imagine the source looks like this, right? We have two arguments. We're going to copy ls Yeah, we're going to copy ls back to argument 0. So now we have ls. That's in this for loop here if we only have 2 arguments. Then before, we would go directly into assigning argv here. So then we get the ls is still stuck here, right? So basically now the last thing we're going to wipe out to null, right? So when we run it, if we're running it with just ls, we get just ls, and that works. And so now actually if I do like factorial 2, and I don't specify enough arguments, yep, or if I do calc, not enough arguments, right? Not enough arguments, bam, there we go. Huh? Oh no, guys. We just did some memory unsafety. These are, this is not right at all. Oh no, the star was just expanding. We're fine. Okay. Yeah, so this star was here before. These are everything in our directory. I thought we just hit something weird in the environment. We were just reading from memory. This is another thing with the speedruns. Not only is it a speedrun, I want to try to speedrun it without violating memory safety, which I think someone will have to remind me, but I think we haven't failed on that yet. And yeah, I want to see how long I can go. Yeah, so this looks like it actually works fully. Yeah, so I'm just going to read through the code here, just to like double check everything's good. And then, yeah, I'll see you in the next one. I hope you guys enjoyed. Special thank you if you made it to the end. I know the last or 2 episodes ago did pretty well. And you guys asked for some things like the keylogger thing, so I put that in. The mic, I put a towel under it this time, so hopefully there isn't time like you've been banging on the keyboard. There's not as much bass and stuff. So yeah, I hope you guys enjoy this a lot, and you stick around. We'll have a lot more to come. The next episode should be doing an actual shell, not this weird hard-coded crap. So yeah, definitely stick around. It'll be a good time. And yeah, peace out.